안녕하세요. Richard Dawkins, Outgrowing God. Chapter 8, Steps Towards Improbability. The previous chapter was filled with amazing examples of animals beautifully built, displaying uncannily perfect color patterns or doing apparently clever things to assist their survivor. After each story, I asked, must there not have been a designer, a creator, a wise God who thought it all out and made it happen? What exactly is it about those examples? And you could tell similar stories for every animal and plant that ever lived. That makes people think there had to have been a designer. The answer is impossibility, and I need to explain what I mean by that. When we say something is improbable, we mean it's very unlikely to just happen by random chance. If you shake 10 pennies and toss them on the table, you'd be surprised if all 10 came up heads. It could happen, but it's very unlikely. If you enjoy arithmetic, you might like to work out just how unlikely, but I am content to say very. If somebody did the same thing with 100 pennies, it's still just possible they'd all come up heads, but it's so very improbable that you'd suspect a trick and you'd be right. I'd bet everything I have that it was a trick. With tossing pennies, it's easy, well, straightforward at least, to calculate the odds against a particular outcome, something like the improbability of the human eye or the cheetah's herd. We can't calculate it exactly just by using arithmetic, like we can with the pennies, but we can say that it's very improbable. Things like eyes and herds don't just happen by luck. It's this It's this improbability that tempts people to think they must have been designed. And my task in this chapter and the next ones is to show that this thinking is mistaken. There was no designer. The improbability remains, whether we are talking about the improbability of an eye or the improbability of a creator capable of designing an eye. There has to be some other solution to the problem of improbable things, and that solution was provided by Charles Darwin. For a living body, the equivalent of tossing pennies might perhaps be to scramble the bits of an eye, say at random. The lens could end up at the back of the eye instead of the front. The retina could be in front of the cornea instead of behind the lens. The iris diap diaphragm could close when it's dark and open when it's light, instead of the sensible way around, or open when you hear a trumpet and close when you smell an onion. The lens could be pitch black and not let any light through, instead of clear and transparent. Even having a retina or an iris diaphragm, diaphragm at all wouldn't happen if you scrambled the bits of them at random. Or imagine a randomly scrambled cheetah. It could have all four legs on one side, or so it keeps toppling over sideways. The rear legs could be stuck on backwards, so they gallop in the opposite direction to the front legs, and the cheetah doesn't move either towards or backwards but tries to tear itself in half. The herd could be connected to the windpipe, so it pumps the air instead of blood. The cheetah could have teeth in its backside instead of in its mouth, and a totally scrambled cheetah wouldn't have legs or herd or teeth at all. It would be a jumbled mass, a pure cheetah smoothie. This is just silly, as I'm sure you realize there's an infinite number of ways you could scramble the bits of a cheetah, and only a tiny number of them could run, or see, or smell, or have babies, or indeed stay alive. There's an infinite number of ways you could scramble the bits of a chameleon, and only a tiny number of them could shoot a tongue out of an insect. It's completely obvious that animals and plants do not come about by random chance. Whatever else is the explanation for cheetahs and gazelles, the lightning fast chameleon tongue, the chromatophores and iridophores and leucophores of a squid. It cannot be a random chance. Whatever is the true explanation for all the millions of animals and plants, it cannot be love. We can all agree about that. So what is the alternative? Unfortunately, at this point, many people go straight down the wrong path. They think the only alternative to random love is a designer. If that is what you think, you're in good company. It's what almost everybody thought until Charles Darwin came along in the middle of the 19th century. But it's wrong, wrong, wrong. It isn't just a wrong alternative, it's no alternative at all. The wrong argument was most famously expressed by the Reverend William Paley in his 1802 book Natural Theology. Imagine you're out for a walk on a heath. Archdeacon Paley said, and you happen to kick a stone. You are not impressed by the stone. It just happens to be there, and it just happens to have the rough, irregular, knobbly shape it has. A stone is just a stone. It doesn't stand out from all the other stones. But now, says Paley, suppose you stumbled over another stone but a watch. A watch is complicated. Open up the back and you see lots of cogwheels, springs, delicate little screws. In Paley's time, of course, this wouldn't have been a modern digital wristwatch. It would have been a mechanical timepiece, a pocket watch with a beautifully and expertly crafted movement, and all those tiny interlocking parts work together to do something useful. In this case, tell the time. Like the stone, the watch couldn't have just happened by luck. It had to have been deliberately designed and put together by a skilled watchmaker. Of course, you can easily see where Paley was going with this. Just as the watch must have had a watchmaker, the eye must have had an eye maker, the hurt must have had a hurt maker, and so on. It's possible you are now even more persuaded by Paley's point than you were before, even more reluctant to hear that it's wrong and that there really is no need for a creator God. The scrambling argument shows that whatever else the explanation of the beautiful improbability of living things may be, It certainly can't be random luck. That's pretty much what improbability means. But now here's a little twist to the argument. It may be little, but it's very important. The Darwinian twist. Suppose that instead of scrambling all the bits of a cheetah at random and making a horrible mess, we change just one little bit of animal again in a random direction. The key point is that we change it only a very small amount. Suppose a cheetah is born with claws just a tiny bit longer than in the previous generation. Now we don't have a horrible mess of scrambled cheetah. We still have a proper living, breathing, running cheetah. It has changed at random, but only very slightly. Now it is quite likely that this tiny change makes the cheetah a little bit worse at surviving, or perhaps a bit better. Perhaps longer claws give the cheetah a better grip on the ground, and this helps it to run just that little bit faster, like the spiked running shoes that athletes wear. So it catches a gazelle that would otherwise have narrowly escaped, or perhaps the claws give the cheetah a better grip on the prey when it's caught, so it has less chance of wriggling free. And how did that cheetah get its slightly longer claws? Somewhere in the cheetah genome, there is a gene that affects claw length. A baby cheetah always inherits its genes from its parents, but we are now talking about a new baby in which a gene which affects the claws, isn't quite the same as the parental version. It changed at random. The gene has mutated. The process of mutation itself is random. It is not specifically guided towards improvement. Most mutant genes, in fact, make things worse, but some, as in our example of the slightly longer claws, happen to make things better, and in that case the animals or plants that possess them are more likely to survive and pass on their genes, including the mutant ones. That's what Darwin called natural selection, although he didn't use the word mutation. A random mutation could make the claws blunter instead of sharper, and maybe less good at running or gripping prey. The smaller the change, the closer the probability gets to 50% that it's an improvement. To see why, imagine that the change is very large. Say the mutant claws are a foot long. That's bound to make the cheetah less successful. It will trip over its monstrous claws and they will break when they try to grip anything. The same will be true of a big change in either direction. If the legs suddenly become 2 yards long or only 6 inches long, the cheetah will perish swiftly. Now think about this very small change again in either direction. Imagine a mutation that is so small as to have almost no effect at all on the cheetah's body. A change like that will have hardly any effect on the animal's success. Either way, a very small change, so small that it is almost but not quite zero, will have an approximately 50% chance of being an improvement. The larger the mutation in any direction, the greater the likelihood that it will damage the animal's performance. Large mutations are bad. Small mutations approach a 50% chance of being good. Darwin realized that successful mutations are nearly always small, but the mutations that scientists study are usually large, for the obvious reason that small ones are hard to detect. And because large mutations in any direction are almost always bad, this has led some people to doubt evolution because they think all mutations are bad for survival. It may be true that all the mutations big enough to be easily studied in the lab are bad for survival, but it's the small ones that matter in evolution. Darwin persuaded his readers of the power of selection by first pointing to domestication. Humans have changed wild horses into dozens of different breeds. Some, like cart horses and medieval chargers, are larger than wild horses. Others, like Shetland ponies and falabellas, are much smaller. We, that is, our human ancestors, made cart horses by choosing to breed from the largest individuals in successive generations. We made falabellas by breeding from the smallest. Generation by generation, we made all the breeds of dogs from all ancestors. We made Great Danes and Irish Wolfhounds by breeding from the largest as the generations went by. We made Chihuahuas and Yorkies by breeding consistently from the smallest, starting with the wild cabbage, which is an ordinary nondescript wildflower. We made Brussels sprouts, cauliflowers, kale, broccoli, kohlrabi, and the mathematically elegant romanescos. All were made by humans practicing artificial selection. Farmers and gardeners, dog breeders, and pigeon fanciers have known about the power of selection for centuries. What Darwin brilliantly realized is that you don't need the human selector. Nature does the job all by itself and has been doing it for hundreds of millions of years. Some mutant genes help animals to survive and reproduce. Those genes become more frequent in the population. Other mutant genes make it harder for them to survive and reproduce, and so become less frequent in the population until they disappear altogether. It only takes a few centuries to turn a wolf into a whippet or a Weimaraner. Just think how much change could be achieved in a million centuries since our ancestors were fish crawling out of the sea. 3 million centuries have gone by. That's an awful lot of time, a huge opportunity for change, step by step down the generations. The key point about mutation, to return to it, is that successful mutations, though random, are small. The mutant animal is not a randomly scrambled mass. Each random change makes it only a little bit different from the previous generation. Let's go back to our cheetah to see how nature does the job of a farmer or gardener or dog fancier. The cub with the mutant gene grows up, and its slightly longer claws help it to run just a little bit faster, so it catches more prey, which means that its cubs are better fed and are more likely to survive and have cubs of their own. Some of these new cubs, grandchildren of the mutant, inherit the mutated gene, so they too grow up with slightly longer claws. They too run extra fast because of it, and they too therefore have more cubs, great grandchildren of the original mutant, and so on. It's as though a human breeder systematically choose the fastest individuals to breed from, but there is no human breeder. Survivor does the job instead. You can see what's going to happen. As the generations go by, the mutated gene becomes more and more common in the population. Eventually, a time comes when almost the entire population of cheetahs has the mutated gene, and they are all running just a little bit faster than their ancestors did. This now puts extra pressure on the gazelles. Not all gazelles can run equally fast. None can run as fast as a cheetah, but some gazelles can run faster than other gazelles, and they are the ones more likely to escape being eaten. This makes them more likely to survive to have babies, and their babies will inherit the genes for running fast. Genes for running slowly are more likely to end up in the bellies of cheetahs, lions, or leopards. And consequently less likely to end up in future generations of gazelles if, again by a random change in an existing gene, a new mutant gene were to arise which helps gazelles to run faster. It would spread through the gazelle population. Just like the cheetah mutation, it could be a change in the hooves, or a change in the herd, or some deeply buried change in the chemistry of the blood. The details don't matter here. If any gene helps gazelles to survive by any means whatsoever, it will get passed on to their children. So, like the cheetah gene, it will eventually spread until it becomes universal in the population. As the generations go by, both cheetahs and gazelles, hunters and hunted, have become just a little bit faster. We say there has been an evolutionary change on both sides. I like the metaphor of the arms race. Of course, an individual cheetah and an individual gazelle literally run a race against each other. But that's not an arms race. That's just a race. And it does ends rather swiftly in victory for either the cheetah a meal or the gazelle escape. Arms races are run more slowly in evolutionary time rather than individual cheetah gazelle time. The arms race is between the gazelle species and the cheetah species, also lion species, leopard species, hyena species, Cape hunting dog species, and the result of the arms race is improvement over the slow evolutionary timescale, improvement in equipment for survival, improvement in running speed as the generations go by, improvement in legs, stamina, dodging skill, sense organs to detect predators or prey, improvement in blood chemistry to get oxygen to muscles fast. Just like in human life, nothing is free. Improvements have to be paid for. Improved running speed demands longer legs with less heavy bones, and that is paid for in increased likelihood of broken legs. Human artificial selection has bred race horses to run faster than natural selection ever did. But race horses' long, slender legs are consequently more likely to break. Imagine what would have happened to wild horses if they had been driven by the arms race against saber-toothed tigers to run as fast as modern race horses. The fastest, the fastest individuals might have been more likely to outrun the saber-tooth with their longer legs and lighter bones, but they'd also have been more likely to break a leg. Then they'd have been easy meat for the saber-tooth. So in practice, we'd expect the arms race to lead to a compromise. Wild horses would run fast, but not quite as fast as human-bred horse. And that's what actually happened. Not surprisingly, modern race horses often do break their legs and tragically have to be shot. And it's not just broken legs and the like that put limits on the arms race. Economic limits are also important. Fast running muscles are costly to make. You need food to turn into muscle. That food could have been put into something else, into making milk for babies, for instance. Human arms races are also economically costly. The more money you put into bombers, the less money is available for fighters. Not to mention less money for hospitals and schools. Think of the economic calculation that a plant, such as a potato, has to do. A plant is a, a plant is a good example because while we might be tempted wrongly to think that a gazelle or a cheetah or a horse does calculations in its head, nobody could seriously imagine that a plant does sums, and doing calculations consciously is exactly what we are not talking about. The, the equivalent of calculations is done by natural selection over the generations. So back to the potato plant. It has a limited amount of money to play with. Money here means the energy sources that ultimately come from the sun, turned into the currency of sugar and often stored as starch. For instance, in a potato tuber, the plant needs to spend some money on leaves to take in sunlight to make yet more money. It needs to spend some money on roots to take in water and minerals. It needs to spend some money on underground tubers to store money for next year. It needs to spend some money on flowers to attract insects to pollinate other potato plants and spread the genes, including genes for getting the spending decisions right. Potato plants that get their calculations wrong, perhaps not spending enough on tuber storage for next year, are less successful in passing on their genes. As the generations go by, plants that get their economic sums wrong become less numerous in the population, and that means that genes for getting economic sums wrong become less numerous. The population gene pool becomes more and more full of genes for getting the economic sums right. Having learned from the potato plant that we are not taking about conscious calculations, we can safely go back to gazelles and talk about how they get their economic balance right. The details are different from the potato, but the principles are the same. Gazelles need to be cautious of cheetahs and lions. They need to be scared They need to keep a watchful eye open and a watchful nose, for they open use smell to detect danger. But importantly, they also need to spend a lot of time eating. Weight for weight, plant food is less nutritious than meat, so a herbivore, herbivore, an animal that eats only plants like a gazelle or a cow, needs to keep eating almost all the time. A gazelle that was too scared would keep running away on the slightest suspicion of danger and wouldn't have enough time to eat. On the African plains, you can sometimes see antelopes and zebras grazing within sight of lions, knowing full well they are there. They keep a wary eye open in case the lions show signs of starting a hunt, but they go on grazing. Over the generations, natural selection has achieved a fine balance between being too scared and therefore not getting enough to eat, and not being scared enough and therefore getting eaten. Evolution consists of changes in the proportions of genes in populations. What we see from outside in changes in bodies or behavior as the generations go by. But what is exactly really going on is that some genes are becoming more numerous in the population and others less numerous. Genes survive or fail to survive in the population as a direct result of their effects on bodies and behavior, only some of which are visible to us. It's not just cheetahs and gazelles, zebras and lions, it's chameleons and squids, kangaroos and kakapoos, buffaloes and but, but, butterflies, beech trees and bacteria. Every animal and plant, every mushroom and every microbe, they all contain the genes that helped an unbroken line of ancestors to survive and pass those genes on. You and I and the Prime Minister, your cat, and the birds singing outside your window, every single one of us can look back at our ancestors and make the following proud claim. Not a single one of my ancestors died young. Plenty of individuals died young, but they are not the ones that became ancestors. Not a single one of your ancestors fell over a cliff, or was eaten by a lion, or died of cancer before living long enough to have at least one child. Of course, that's obvious when we think about it, but it's really important. It means that every single one of us, every animal and plant and fungus and bacterium, every one of them, every one of the 7 billion people around the world contains genes for being good at surviving and becoming an ancestor. The details of what makes us good at surviving vary from species to species. For cheetahs, it's sprinting. For wolves, it's long distance running. For glass, it's being good at absorbing sunlight and not minding too much about being cropped by cows or lawnmowers. For cows, it's being good at digesting glass. For hawks, it's being good at hovering and spotting prey. For moors and aardvarks, it's being good at digging. For all living creatures, it's getting the economic balance right. It's being good at thousands and thousands of things all working together through every corner and cranny of the body, through every one of billions of cells. The details vary hugely, but they all have one thing in common. They are all ways of being good at passing on genes to future generations, passing on genes that make them good at surviving, and passing the same genes on, just different detailed ways of doing the same thing, surviving and passing on genes. We agreed that an eye or any organ that's complicated like Paley's watch is too improbable to have just happened, like Paley's stone. An excellent seeing device like a human eye cannot spring spontaneously into existence. That would be too improbable, like throwing 100 pennies down and getting all heads. But an excellent eye can come from a random change to a slightly less excellent eye, and that slightly less good eye can come from an even less good eye, and so on, back to a rather poor eye. Even a very, very poor eye is better than no eye at all. You can tell the difference between night and day, and perhaps detect the looming shadow of predator. And the same kind of thing is true not just of eyes but of legs and hearts and tongues and feathers and blood and hair and lips. Everything about living creatures, no matter how complicated, no matter how improbable as Paley's watch, can now be understood. Whatever it is that you are looking at it didn't spring into existence at all at once. Instead, it came from something just a little bit different from what went before. Improbability dissolves away when you see it as arriving gradually, stealthily, step by tiny step, where each step brings about only a really small change, and the first step may not have brought about anything very good at all. Improbable things don't just into the world suddenly. As I said before, that's what improbable means. Paley, Paley was right about the watch. A watch cannot spring spontaneously into existence. It has to have a watchmaker. Watchmakers too don't spring spontaneously into existence. They are born as complicated babies, human babies that grow into human adults with human hands and brains and ability to learn a skill like watchmaking. Those human hands and brains evolved gradually from ape hands and brains. Those apes evolved gradually from monkey-like ancestors. They in turn evolved by gradual, slow, painfully slow degrees from shrew-like ancestors, from fish-like ancestors before that, and so on. It was all gradual, slow, never sudden, never improbable like a watch spontaneously springing into existence at one go. Designers need an explanation just as watches do. Watchmakers have their explanation, being born from a woman, and before that by slow, gradual evolution through a very long chain of ancestors. The same explanation as for all living things. So where does that leave God, the alleged designer of everything? If you don't think about it very hard, God seems to be a good explanation for the existence of improbable things like chameleons and cheetahs and watchmakers. But if we think about it more carefully, we can see that God Himself is even more improbable than William Paley's watch. Anything clever enough, complicated enough to design things has to arrive late, late in the universe. Anything as complicated as a watchmaker must be the end product of a long, slow climb from earlier simplicity. Paley thought this watchmaker argument established the existence of God, but when properly understood, the very same argument goes in exactly the opposite direction, in the direction of disproving God's existence. Little did Paley know that he was eloquently and persuasively shooting himself in the foot. 감사합니다.